GATE is a competitive examination taken by millions of students in India every year. Based on the February 2016 question paper, in the Computer Science and Information Technology branch, a question on the theory of computation. There is a problem. GATE 2016 Theory of Computation, Paper 1, Computer Science and Information Technology, question 43. It's a multiple choice question involving push-down automata. Here is the push-down automata, question 43. Consider the transition diagram of a push-down automata given below. Input alphabet is AB. Stack alphabet is XN, Z. Z is the initial stack symbol. L is the language accepted by the push-down automata. Start state is final state. Here is the final state. Which one of the following is true? There are 4 choices. It's a multiple choice question. One of the choices is correct, 3 of them are wrong. A says the language A and BN, which we know the standard context-free language which is not regular, is not accepted by any finite automata, but is language accepted by this. C says L is not accepted by any Turing machine that falls on every input. B and D, if you look at these languages, they are the same. But this says L is deterministic context-free. This says L is not deterministic context-free. One of the choices is correct. You will examine each choice and eliminate the bad choices. Here, for example, are the regular languages. Above that, the context-free languages. Above that, we have context-sensitive languages. Above that, the RE6. The push-down automata accept the context-free languages. The Turing machines accept the RE6. Also, Turing machines that halt accept the recursive sets. Either way, Turing machines are above the push-down automata. Anything a push-down automata does can be simulated by a Turing machine, which halts on all inputs. So, choice C says L is not accepted by a Turing machine that halts on every input. C is false. Choice C can be eliminated. Now we will try the behavior of the machine on small strings. We will try strings A on string B. What happens? The start state is a final state. A is accepted by this push-down automata. So once we say A is accepted, consider this language. N is greater than or equal to 0. When A comes, B must come. So A is not in L. In other words, this language cannot be accepted by this push-down automata. So A and C can be eliminated. We are left with B and D. Now, if I examine this push-down automata in this state, A on input X and A on input Z, the behavior is clearly defined and different. B on input X, B on input Z, behavior is defined and different. In this state, A cannot come in. B on input X, clearly a move is there. B on input Z clearly is rejected. Epsilon on Z remains in Z. In this state, there is no choice between an epsilon move and a true symbol. So this machine is very much a deterministic push-down automata. All states in this move are deterministic. All moves in this state are deterministic. All moves in this state are deterministic. The PDA is deterministic. This language and this language is the same. So obviously, it's a deterministic context-free language for push-down automata, deterministic. D is going to be the correct choice. When we examine the PDA, we see it's deterministic. There is no non-determinism in any choice in any move. So what we have is deterministic push-down automata. We need not worry about what it accepts. It accepts the deterministic context-free language. The answer is automatically D. We don't have to worry about the language as it's automatically a DCFL. And we'll assume the examiner is taking care of everything else being in order. The answer is D. End of the presentation. Thank you very much for your kind attention.